There's a country in the heart of Europe that doesn't make sense. Not politically, not historically, genetically. When scientists map European DNA, when they trace ancestry across the continent, when they analyze migration patterns spanning thousands of years, the same pattern emerges over and over. Everything converges in Germany. Hunter-gatherer lineages from the Paleolithic, farmer ancestry from the Neolithic, steppe pastoralist DNA from the Bronze Age, Celtic markers, Roman genes, Slavic haplogroups, Scandinavian variants, they all meet in Germany, not equally distributed across Europe, concentrated in Germany. And for decades, geneticists couldn't explain why. Why does a country that didn't exist as a unified nation until 1871 contain more genetic diversity than countries twice its size? Why do Germans in the north look genetically Scandinavian? Germans in the south look Alpine. Germans in the east look Slavic, and Germans in the west look French, even though they all identify as German? Why is Germany the only major European country where you can travel 100 kilometers and find populations that are genetically more different from each other than Italians are from Greeks? The answer isn't what you think. It's not about invasions. It's not about conquest. It's not about Germans absorbing other populations. It's about something far more fundamental. Germany is where Europe never stopped. While other regions were depopulated by ice, isolated by mountains, cut off by seas, or bottlenecked by catastrophes, Germany remained open, a crossroads, a highway, a place where people moved through, settled, mixed, and stayed, layer upon layer upon layer for over 40,000 years. Germany didn't create European genetic diversity, it preserved it. And understanding why requires rethinking everything we thought we knew about how populations form, how nations emerge, and what it means to be European. Let's start with a fact that will reframe everything. Most of Europe was depopulated multiple times, completely emptied of humans. During the last glacial maximum, 20,000 years ago, ice sheets covered Scandinavia, Britain, Ireland, and much of Northern Europe. These regions were uninhabitable. No one lived there. The populations that exist there today are descendants of people who recolonized those areas after the ice retreated. Even southern Europe, which wasn't covered in ice, experienced severe population bottlenecks. Iberia became a refuge, but a small one. Italy was fragmented by mountains. The Balkans were a corridor, not a homeland. Population shrank. Genetic diversity collapsed. And when people eventually returned to these regions, they carried only a fraction of the genetic variation that had existed before. But Germany never emptied. Even during the Ice Age, the river valleys of the Rhine, Danube, and Elbe remained ice-free. Not tropical, not comfortable, but survivable. Archaeological evidence shows continuous human presence in what is now Germany for over 40,000 years. That's not just survival, that's persistence. An unbroken genetic thread stretching from the Paleolithic to the present. And here's why that matters. When a population goes through a bottleneck, when it shrinks to a few thousand people or gets wiped out entirely and then recolonizes, it loses genetic diversity. Rare variants disappear. Lineages go extinct. The population that re-emerges is genetically simpler, more uniform. But when a population never bottlenecks, when it maintains continuous presence even through the worst environmental conditions, it accumulates genetic diversity. Old lineages persist alongside new arrivals. Variants that would disappear elsewhere survive. Germany became a genetic archive, a repository of European ancestry that elsewhere was lost. Consider this. Haplogroup I, the ancient Paleolithic European lineage carried by the original hunter-gatherers, is rare across most of Europe, diluted or replaced by later migrations. But in Germany, particularly in the river valleys of the Rhine and Danube, Haplogroup I persists at elevated frequencies, not because Germans are pure hunter-gatherers, but because Germany never fully replaced its original populations. When Neolithic farmers arrived from the Near East around 7,000 years ago, they didn't wipe out the hunter-gatherers, they mixed with them. When Bronze Age Steppe Pastoralists arrived 5,000 years ago, they didn't erase the farmers, they absorbed them. Germany's genetic diversity isn't a product of recent mixing, it's a product of never resetting, of layers accumulating, one on top of another, preserved by geography that allowed survival when elsewhere populations vanished. But survival alone doesn't explain Germany's genetic complexity. Plenty of regions survived the Ice Age. What makes Germany unique is connectivity. And the key to understanding that connectivity is water, rivers, the Rhine, flowing from the Alps to the North Sea, The Danube, connecting Central Europe to the Black Sea and beyond. The Elbe, linking the interior to the Baltic. The Oder, marking the eastern frontier. These weren't just trade routes, they were genetic highways, moving people, ideas, and DNA faster and farther than any army ever could. Here's what we get wrong about ancient migration. We imagine it as invasion, armies crossing borders, conquerors replacing natives. But most genetic movement in prehistory wasn't violent. It was economic. Merchants moving goods, families relocating for trade opportunities, women marrying into distant communities, slaves being transported along river networks, pilgrims traveling to religious centers. And all of this movement followed rivers, because rivers were the infrastructure of the ancient world. They provided transportation, water, fish, and fertile land. Settlements clustered along rivers. Trade networks followed rivers. And marriages connected river communities across hundreds of kilometers. When geneticists analyze ancient DNA from Germany, they find something remarkable. Even in the Bronze Age, 4,000 years ago, communities separated by just 50 kilometers along the same river show clear genetic exchange. But communities separated by the same distance across a mountain range show almost no mixing. Rivers connected, mountains divided, and Germany sits at the intersection of Europe's greatest river systems. The Rhine connects the North Sea to the Alps, linking Germanic tribes to Celts, Romans, and Mediterranean populations. The Danube connects Central Europe to the Balkans and the Black Sea, linking Germans to Slavs, Thracians, and steppe peoples. The Elbe and Oder connect the interior to the Baltic, linking Germans to Scandinavians and Baltic tribes. Germany wasn't a nation, it was a junction, a place where river networks intersected and where every population moving along those networks left genetic traces. And here's the key insight. DNA followed water, not borders. Modern Germany's genetic diversity doesn't reflect German expansion. It reflects thousands of years of movement along river systems that happened to converge in the region we now call Germany. The people who lived there didn't conquer Europe. They absorbed the movement of Europe flowing through their rivers. But what about the invasions? The great migrations that supposedly reshaped Europe? The Celts, the Romans, the Germanic tribes, the Slavs? Didn't they replace populations through conquest? Here's where archaeology and genetics tell a very different story than traditional history. Most invasions were thin-layer elite takeovers, not population replacements. A small group of warriors, elites, or colonizers would arrive, establish political control, impose their language and culture, and within a few generations, the entire region would be labeled as belonging to that new group. But genetically, the local population remained largely unchanged. Take the Bell Beaker phenomenon, around 2500 BCE. For decades, archaeologists debated whether Bell Beaker culture spread through migration or through cultural diffusion. Then ancient DNA provided the answer, both, but not evenly. In Britain, Bell Beaker arrival coincided with a near-total replacement of the local population. Over 90% of the genetic ancestry changed within a few centuries. But in Germany, Bell Beaker peoples arrived, established themselves, and mixed with the existing population. The genetic impact was significant, but not erasure. Local lineages survived alongside the newcomers, or consider the Roman Empire. Rome conquered Germany up to the Rhine and Danube. Roman forts, cities, and infrastructure were built. Latin became the administrative language. But how many Romans actually settled in Germany? Genetic studies suggest the Roman presence was administratively significant, but genetically minimal. Roman soldiers, often recruited from across the empire, married local women. Their children were raised bilingual, Roman in culture, but local in ancestry. When the empire collapsed, the Roman identity disappeared, but the genes remained, integrated into the local population. The same pattern repeats with the Germanic migrations of the 4th to 6th centuries CE. Small groups of warriors and elites, maybe a few thousand people, would conquer a region, establish kingdoms, and impose their language. But the bulk of the population, the farmers, the craftsmen, the laborers, remained the same families who had been there for centuries. Power changed faster than blood. Culture shifted. Languages evolved. Political boundaries were redrawn. But the genetic substrate, the foundational ancestry of the people, remained remarkably stable. Germany shows this pattern more clearly than anywhere else in Europe because Germany never had a single conquering elite that homogenized the population. Instead, it experienced hundreds of small-scale elite replacements, each leaving a genetic trace, none erasing what came before. So why didn't Germany experience the kind of genetic bottlenecks that reshaped other European populations? Why didn't a single invasion or catastrophe reset the genetic clock the way it did in Britain, Iberia, or Scandinavia? The answer is geography. Germany has no kill switch, no geographic feature that could isolate and reset its population. Britain is an island. When new populations arrived, the sea prevented easy escape or reinforcement from the continent. Populations were trapped, either replaced or absorbed completely. Iberia is a peninsula cut off from Europe by the Pyrenees. Populations there became isolated, creating genetic refugia that preserved unique ancestry but also limited diversity. Scandinavia was covered in ice during the last glacial maximum and recolonized from the south, creating a founder effect that reduced genetic diversity. Germany had none of these isolating features. No sea, no mountain walls, no ice-imposed resets, just open plains, river valleys, and forests. And that openness meant populations could move in, move out, move through, and mix continuously without ever creating the conditions for a total genetic replacement. Even when catastrophic events occurred, the Black Death in the 14th century, the 30 Years' War in the 17th century, which killed up to 30% of Germany's population, the genetic impact was temporary. Neighboring populations moved in to fill the vacuum. Refugees returned, and within a few generations, genetic diversity was restored. Germany's geography prevented isolation, and isolation is what creates genetic uniformity. Without it, Germany remained diverse. Compare this to Iceland. Iceland was settled by a small founding population in the 9th century CE, a few thousand Norse and Celtic people. And because it's an island, isolated from Europe, that founding population created a genetic bottleneck. Modern Icelanders are genetically homogeneous, descended from those few thousand founders. Germany experienced no equivalent founding event because it was never isolated long enough for one to occur. But here's where Germany's story gets truly fascinating. Because while Germany absorbed populations continuously, it also erased their distinct identities, not through violence, but through integration. A person living in what is now Bavaria in 500 CE might have identified as Celtic. By 800 CE, their descendants identified as Bavarian, a Germanic tribe. By 1200 CE, they identified as subjects of the Holy Roman Empire. By 1871, they identified as German. Same families, same land, same genes, but the labels changed. And that's the illusion we need to confront. When we talk about Germans genetically, we're not talking about a single population that spread out and conquered Europe. We're talking about a geographic region where countless populations converged, mixed, and were relabeled over time. Modern genetic studies reveal this starkly. When researchers analyze German genomes, they find that a single German individual can carry Celtic maternal lineages, Roman paternal markers, Slavic autosomal ancestry, and Scandinavian variants, all within the same genome. This isn't because that person's ancestors moved around Europe. It's because Europe moved through Germany. The Celts, who lived in southern Germany 2,500 years ago, didn't disappear when the Romans arrived. They became Romanized Celts. When Germanic tribes took over, they became Germanic Celts. When those regions were Christianized and integrated into the Holy Roman Empire, they became Germans. The genetics didn't change. The identity did. And this reveals something profound about how we misunderstand European history. We treat cultural labels as if they represent distinct genetic populations. We say the Celts, or the Romans, or the Germans, as if these were separate peoples who replaced each other. But genetics shows that most of the time, these labels describe political and cultural shifts, not genetic replacements. The same families stayed on the same land, absorbing new languages, new religions, new political systems, while maintaining genetic continuity across thousands of years. And here's the final piece of the puzzle. Germany didn't unify politically until 1871. That's astonishingly late. By the time Germany became a nation-state, France had been unified for centuries. Britain had a centralized monarchy since the Middle Ages. Spain had consolidated under the Catholic monarchs in the 15th century. But Germany remained a patchwork of hundreds of independent principalities, duchies, free cities, and ecclesiastical states until the late 19th century. And that political fragmentation had a profound genetic consequence. It prevented homogenization. When a state centralizes early, when a single political authority controls a large territory, populations begin to mix. Soldiers are recruited from across the kingdom. Administrators are relocated. Trade routes integrate distant regions. Marriages connect noble families across provinces. Over centuries, this creates genetic convergence. Regional differences fade as populations mix under a unified state. But Germany didn't have that. Germany had endogamy within valleys and towns. Families married locally, within their principality, within their dialect region, for centuries. And that preserved regional genetic differences that elsewhere in Europe were erased by state formation. Modern genetic studies show this clearly. The genetic distance between a Bavarian and a North German is greater than the genetic distance between a Spaniard and a Portuguese. Germans in the Rhineland cluster genetically closer to the French than to Germans in Saxony. Germans in the East show Slavic ancestry that Germans in the West completely lack. Germany isn't genetically homogeneous. It's a mosaic of micropopulations, each preserving distinct ancestry, each representing a different combination of the migrations, invasions, and mixtures that occurred in their specific region. And those genetic borders are older than the German state. They reflect medieval principalities, Roman provincial boundaries, and even earlier tribal territories. Political Germany is 150 years old. Genetic Germany is thousands of years old. Germany shows us what Europe looks like without isolation myths. It shows us that populations don't replace each other cleanly, that invasions are usually elite takeovers, that culture changes faster than genes, and that the labels we use, Celtic, Roman, Germanic, Slavic, describe political and linguistic shifts, not genetic replacements. Germany is the crossroads, the place where everything met. And if you want to understand Europe, don't look at its edges, where isolation created genetic refugia and national myths. Look at the center. Look where the rivers meet. Look where nothing ever stopped moving. Look at Germany. If this reframe of German genetics and European history resonated with you, share it with anyone curious about how migration, geography, and politics shape who we think we are. Have you taken a DNA test and found unexpected ancestry? Do you think national identity should be based on genetics, or is it purely cultural? And if every European nation is genetically mixed, why do we still cling to myths of ethnic purity? Leave your thoughts in the comments. Germany didn't choose to be Europe's genetic crossroads. Geography made that choice 40,000 years ago. And the DNA is still here, written in the genes of millions, telling a story more complex than any border, any language, any nation could ever contain. Thanks for watching.